bucka. Haha. You know the deal.
The next thing we're going to talk about with integers is another operation, and we're going to talk about multiplying integers. So the first thing we're going to talk about is the fact that you have multiplied integers before. From when you first learn how to multiply, you are multiplying integers, but as discussed before, pretty much up to this point, you've only dealt with positive integers. So here I've started writing out the 5 times tables. And because there's no symbol to the left of the number, we can assume that all of these values are positive values. And we know that the answer to 5 times 5 is 25. And once again, usually we don't say the sign with that, but since there is no sign in front of it, we assume it's a positive. It's a positive 25. And so that means 5 times 4 would be positive 20. And so on. So all of the answers that we're going to get here are going to be positive values. Until we get to the 5 times 0, and anything times 0 is 0. And as discussed before, 0 is neither negative or positive. It's just 0. So what we can see from this, and from all of the multiplication that you've done so far, is that when we multiply two positives, a positive times a positive, the answer is always a positive. Now, if I were to continue this pattern here in terms of our 5 times tables, since it's our 5 times tables, we're always multiplying by positive 5. But if we continue to follow this pattern in terms of what we're multiplying positive 5 by, you can see we're going down by values of 1. So if we continue going down by values of 1, the next times question is going to be positive 5 times negative 1, because we've gone from positive 5, positive 4, positive 3, positive 2, positive 1, 0. Well, the next value has to be times negative 1. If you look at the answers to these questions, you can see there also is a pattern there in the answers. The pattern is that the values seem to be going down by 5s. So we're at 25, 20, 15, 10, 5, 0. So if we're going to continue that pattern, the answer to this has to be negative 5. And then if we continue on with the pattern in terms of what we're multiplying positive 5 by, we're continuing to go down by 1, moving left on the number line. The next value we're going to multiply the positive 5 by is negative 2. And if we also continue to go down by values of 5, the answer to that has to be negative 10. And we can continue. So we're going to continue with our positive 5 times tables. The next value we're going to multiply that by would have to be negative 3. And the answer to that has to be negative 15. So what you probably start to recognize here is when we're multiplying a positive times a negative, the answer always seems to be a negative. Now, the nice thing about multiplication is it doesn't matter what order you do the multiplication in. So, for example, if we were to do a multiplication 3 times 4, well, we know that 3 times 4 equals 12. But with multiplication, just like with addition, you can switch the order of the numbers and the question doesn't change. Now that's not true for subtraction or division, but with multiplication it is. So 4 times 3 is also 12. Well, because of this property, we can take any one of these examples over here, and if we just switch the order of the numbers, the answer should be the same. So for example, instead of positive 5 times negative 2, if we do negative 2 times positive 5, then the answer is still negative 10. So switching the order of the numbers doesn't actually change the answer. So what we can see here is if we multiply a negative times a positive, the answer is still a negative. So we're going to continue exploring this multiplication of integers by looking at the patterns that we see. And here what we're looking at is the timetables for -3. So as we already saw, when we multiply a negative times a positive, the answer is a negative. Usually when you're multiplying integers, you do so in two steps. First you figure out what the sign of the answer is, and here the sign of the answer is a negative, and then you figure out what the digit of the answer is. And to get the digit of the answer, you just multiply the two numbers together. So 3 times 5 is 15. For the next example, a negative times a positive is a negative. 3 times 4 is 12. And as we continue on, we continue working on our -3 times tables. So the next one is -9, -6, -3, and then finally anything times 0 is 0. Well, if we're going to continue this pattern of multiplying our -3 times tables, we can see once again that the values that we're multiplying by are decreasing by 1. So we're going to continue multiplying -3, but if we continue to now decrease by values of 1, our next question should be -3 times -1. And then still doing our -3 times tables, our next question should be -3 times -2, and so on. Well, now if we look at the pattern in terms of the answer, the values seem to actually be increasing by 3. From -15 to -12, we're moving to the right on the number line. And if we're moving to the right on the number line, that means we're going up by 3. And that does seem to be what's happening each time here. For each one of the -3 times tables, we're going up by 3. So if we continue that pattern, well, if we're going to go up by 3 from 0, it should be +3. And then +6 and +9. And so what we can establish from this pattern is that when we multiply a negative times a negative, the answer is a positive. So over here on the right, we've kind of established our rules for multiplying. Now, I just want to point out that when we think about multiplying, the last video we talked about adding and subtracting, and we talked about a process and some understanding in terms of how that works. Multiplying is completely different than adding and subtracting. And here we've established our rules for multiplying integers, and these rules will always work. So whenever you multiply two positives, the answer is a positive. Whenever you multiply two negatives, the answer is a positive. If you multiply a positive times a negative or a negative times a positive, the answer is a negative. To simplify these a little bit further, you'll notice that if you're multiplying and the signs are the same, so if the signs are both positive or both negative, then the answer is always positive. If you're multiplying and the signs are different, so if one is a positive and one is a negative, or one is a negative and one is a positive, then the answer ends up being a negative. And again, these rules are completely different from what we established in terms of adding and subtracting integers. These rules do not work for adding and subtracting, only for multiplying. So next, let's just look at a couple of examples where we're multiplying two integers together. So for the first one, we have +3 times +8. And as discussed, whenever you're multiplying integers, there's really two steps. The first step is figure out what the sign of the answer is. Here we're multiplying a positive times a positive, and so the sign of the answer is a positive. And second, you figure out the digit of the answer by simply multiplying the digits together. 3 times 8 is 24. So +3 times +8 is +24. For the next one, -7 times +5, well, a negative times a positive is a negative, and 7 times 5 is 35. Carrying on, +4 times -2, a positive times a negative. The signs are different there, so the answer has to be a negative. And 4 times 2 is 8. And finally, a negative times a negative. The signs are the same there, so the answer is a positive. And 6 times 9 is 54. So now that we've talked about multiplying integers, the next thing we're going to talk about is dividing integers. And we're going to use the relationship between multiplication and division to explore how dividing integers works. So if we take a question like 3 times 4, for example, we know that 3 times 4 equals 12. Well, we can extrapolate a couple of division questions from this multiplication question. If we take the answer to this multiplication question and divide it by either one of the other numbers here, so suppose we had 12 divided by 4, well, we know the answer is 3. Similarly, we could also take the answer to the multiplication question and divide it by the other number, so 12 divided by 3 has to be equal to 4. Now, just as with all the other examples, these are the types of division questions you've seen ever since you started working with division, and all of these questions involve positives. So we talked about the fact that a positive times a positive is a positive, but for these division questions as well, all of these values are positive here as well. So we have positive 12 divided by positive 4, and that is equal to 3, which is the same as saying positive 3. Positive 12 divided by positive 3 is 4, which is also the same as saying positive 4. And this is where you can really see separating the signs from the operations is handy. We want to put brackets around these. Don't confuse the positive sign with addition. So looking at these two examples, and we could do several more, but what we can see here is that when we divide a positive divided by a positive, the answer is always a positive. So let's look at another example of a multiplication question, and then we'll extrapolate some division questions from that. This time let's throw a negative in there. So suppose we have something like negative 6 times positive 3. Well, as we just talked about, when you're multiplying integers, you want to go through two steps. Figure out what the sign of the answer is first, and a negative times a positive is a negative. And then you figure out the digit of the answer by just multiplying the digits. 6 times 3 is 18. Well, now if we take the answer to this, negative 18, and we divide it by either one of those numbers, let's start by dividing it by positive 3. We know the answer has to be the other number. So the answer to that has to be negative 6. We could do several other examples, but again, what we've established here is a negative divided by a positive is a negative. So here's another example of a multiplication question. This time we're multiplying a negative times a negative, and as we just discussed, a negative times a negative equals a positive. 5 times 4 is 20. We extrapolate either one of the division questions here. Let's do positive 20, so take the answer to that multiplication divided by negative 4, say, and the answer has to be the other number. So the answer here has to be negative 5. So now we can see that a positive divided by a negative is a negative. So one more example we're going to look at here, where we have our multiplication question and answer, and we're going to take the answer to that multiplication question and make a division question that relates to it. So let's do negative 21 divided by negative 3. And the answer to that should be the other number, and in fact it is the other number. So negative 21 divided by negative 3 is positive 7. And what we can see here is if we divide a negative divided by a negative, the answer is a positive. Now, these rules should look familiar because the rules for division are exactly the same as the rules for multiplication. So the nice thing about this is you don't have to memorize a separate set of rules for division. They're exactly the same. And once again, I got to point out, division and multiplication is a lot different than adding and subtracting. And in fact, when it comes to integers, multiplying and dividing is actually, it's a bit easier than adding and subtracting. We've got these rules that we've now established, and they're always going to work, and they always stay the same. Whereas with adding and subtracting, it's a little bit more complicated. You have to think about a number line, which direction you're moving on the number line, and where you end up. But these rules for dividing, which are the same as for multiplying, are the same every time. So to finish off our video on multiplying and dividing integers, I'm just going to ask you to answer a few questions here. So for question number 1, we're just multiplying. So again, you want to go through 2 steps. First, figure out the sign of the answer, and then figure out the digit of the answer. With the last question in number 1, question 1D, there's a couple of steps there. So you're going to have to first of all figure out what -2 times -3 is, take the answer to that, and then multiply it by -4. With question number 2, you're pretty much exclusively dividing. So again, figure out what the sign of the answer is, and then the digit of the answer. With the last one, you're going to answer the division question first. So you're going to answer -15 divided by -5, take the answer to that, and multiply it by -3. If you're able to answer those questions, congratulations, you now have a firm understanding of multiplying and dividing integers.